right, so now we're going to combine our knowledge from the extreme value theorem and Fermat's theorem into what we call the closed interval method, because on a closed interval, right, the extreme value theorem says yes, there is an absolute or I guess absolute minimum and maximum. So we know those exist, and via Fermat's theorem we now have the critical numbers where we can look for local extreme values as well. Okay, so the kind of the process you're going to use with the closed interval method is, okay, well, first of all, recognize when you need to do it. So you're going to be on a closed interval, okay? But nevertheless, what you're going to do is find your critical numbers, okay? And find the values at the endpoints, okay? And then what you're going to do, at least to classify the absolute extreme values, that's where this comes into play. If you want to classify the absolute extreme values, you're going to generate a list of those critical numbers and the endpoints, and say that the largest of those is, or the largest y value that is going to be where you have the absolute maximum, and the smallest is going to be the absolute minimum. Okay, so I'm going to do the first one with you. Okay, so we want to find the absolute extreme values. I don't care right now about the locals. We can, but I'm going to find the absolute first. So I'm going to do step one is find the critical number. So I'm going to look at f prime of t. And this is going to be negative sine 2t times 2 plus 2 cosine t. Okay, and so then if I set this equal to 0 and solve, right, I would have, 2 sine 2t is equal to 2 cosine t. And now here, it might be, well, maybe I'll leave it like this for now. I'll actually just leave this as, I'll rewrite it as 2 cosine t, and then minus 2 sine 2t, okay, is equal to 0. And what I'm going to do is use the double angle formula, so 2 cosine t minus 2, or actually minus 4 sine t cosine t is equal to 0. And now I can factor this, so I'd have 2 cosine t, and this will be 1 minus 2 sine t is equal to 0. And now I can use the zero product property and say, okay, well, cosine of t is equal to 0, or if I manipulate this a little bit, I'd have sine t is equal to 1/2. And then I can find values of t that satisfy this. So this would be pi over 2 plus pi k. And then this next one would be pi over 6 plus, well, it'd be pi over 6 and 7 pi over 6. And then each of these plus 2 pi k. Oops, 2 pi k. Okay, now I haven't taken into account the interval yet, okay, so that will force our hand in a little bit. But now what I want to do is I want to evaluate according to the closed interval method, right? I need to evaluate the values of f at the endpoints. So I'm going to look at f of 0. F of 0 and say, well, if f is 0, what do I get out? I get 1. And f of pi over 2, if I evaluate this, I get 1. Okay, but now what I want to do is take the information I've gathered from parts 1 and 2 and make a list. Okay, so 3. I'm going to say here's t and here's f of t. Okay, so I have 0 as a t value, and I know that f of t is 1. Oops, and I think I miscalculated here. This should be 1.5. Okay, I'm sorry, no, that was 1. Okay, and then the next value, so I have pi over 2, 7 pi over 6, this gets tossed out because it is outside the interval. So I have to look at pi over 6, okay, and I'll let you calculate that out, but I got 1.5 when I did the calculation. And then I also have to check pi over 2, and those are the only values I found, either that were critical numbers or that were endpoints in my interval. Okay, so what the closed interval method says then is that the largest value is going to be my local max. So that occurs here. So I'm going to say there's a local, or not local, absolute rather. So there's an absolute max of 1.5, so my y value at t is equal to pi over 6. And then the smallest of these, which happen to be the same, those are going to be your absolute min. So absolute min of 1 at t is equal to 0 and pi over 2. Okay, so I would report that as my final answer here, and I would be done. Okay, so just to recap, I found my critical numbers. Then I evaluated the endpoints of my interval into the function. And then in summary, I took the critical numbers, found their y value, and I took the endpoints and put all of those in a table. And then the largest was a absolute max, then the smallest was an absolute min. Okay, so now you have the task of doing one more problem on your own. I want you to tackle it and then resume the video when you're ready to see the solution. And here you go. Okay, only item of note here is that -1, actually that should just be x. -1 was not in the interval. Okay, so I had to toss that out and just go with the positive. Okay. So then the only question is, we've classified absolute mins and maxes, right? But what about the critical numbers? So in the first one, we ended up getting, actually in both of these, we ended up getting the critical numbers being absolute extreme values, but what about local extreme values? What can we say about those? And so that's where we're going to pick up with in the next video.